wanted to thank Mike McGuirk for joining us for the latest installment of the Payne podcast. We're here to talk to him about mining plastic, his paper on harvesting stored energy and reuse revolution. I think it's really interesting, and thanks for joining us, Mike.
Yeah, I'm really happy to be joining you today.
So the tagline on your paper is, to spur action, the perception of discarded plastics must change from burdensome waste to a physical store of non-renewable resources. Major investment in developing catalysts, processes, and infrastructure for energetically efficient chemical recycling is critical. It's time for governments to commit to mining plastics. So most people know that plastics aren't very good for the environment, but how would you characterize their use and the level of pollution these days?
Well, right off the bat, I kind of want to point out that this idea of mining plastic, it's really, a play on words being at School of Mines and whatnot. But, what we're really trying to focus on is this idea of that plastic waste is made up of oil. All of the core components of plastics are the same type of oil that's used in our car. And so what we're doing is when we use these plastics, we're just throwing them out. And so what we're effectively doing is throwing out oil. Kind of the whole idea here is that can we develop some new type of chemistry, myself coming from the chemistry department, in order to pull those resources back out of plastics, which is currently really hard to do. And so I think from kind of the economic standpoint, that's the selling point on this, is that can we develop some new chemical approach to harvesting a resource? Because in any sort of technology like this, effectively recycling, is that if there's no sort of economic payback, there's not going to be any sort of motivation for governments or private industry to extrapolate out the technologies we develop in the lab into more real world application and broad application. Of course, the other real big motivation factor for trying to develop technologies to offset plastic waste is the environmental concern. It's kind of overwhelming to think about just how much plastic we use every single day, especially in a country like the United States. With the amount of plastic that we're using, we've seen just monumental growth in the amount of plastic that's been used. And because of kind of the culture that's been built around it, is we use something and we throw it out, is that an immense amount of plastic is being leaked into our environment. And kind of the crazy stat that gets thrown around these days coming out of the Ellen MacArthur Foundation in England is that by 2050, unless we do something radical, that there's going to be more plastic waste in the ocean by weight than there are fish in the oceans. And just really let that settle in your mind, and just how crazy of a stat that is. And so what we're trying to do in my lab here at Mines, and then in collaboration with other groups across chemical engineering, and then with Morgan Bazilian at the Payne Institute, is try to develop kind of holistic models from core chemical technologies to full-blown processes, and what would be required from a policy and economic driving force point of view to make these things really desirable to be employed at the scale that they would be necessary.
Wow, that statistic is terrifying. More plastic than fish in the ocean.
That's really one that catches people. If they're only half in on the story, when they hear that, they're like, oh, that is absolutely insane.
Yeah. So you mentioned that recycling isn't really cutting it. And I know that's kind of a problem in the United States, especially since we're terrible at recycling. But could you explain why it's not really an efficient method of mitigating plastic pollution?
Yeah, sure. So, I think the first thing to kind of really realize is that, so I'm 31 years old. And ever since I was a kid, in the 90s, I remember all the cartoons and the PSAs, recycle, recycle, recycle. And so we were always kind of trained to think that if I take my plastic bottle and I put it in the recycling bin, that plastic's going to be used to make another water bottle. But the reality of the situation is that recycling as we know it, what's called mechanical recycling, or the physical grinding of the plastics, kind of melting them down and reusing them, it inherently reduces the properties of the plastic. So the plastic is no longer as functionally dependable as it was initially. A water bottle, when recycled, doesn't get turned back into a water bottle because it doesn't have the same properties anymore. Usually what happens is that if a water bottle is collected for recycling, that it could turn into something like carpet. And so this is called downcycling. What we see is that, according to the latest statistics, only about 14% of plastics are actually even collected for recycling, I should say. And in that huge picture, only 2% total of plastics are recycled in what we call closed loop. And this would be a water bottle becoming a water bottle. But that can only happen once, because then it'll get degraded the second time it's recycled. So one, we have this inherent limitation that's called downcycling, or because of mechanical recycling, breaking down the polymers. The polymers are the chemicals that make up the plastics. And so they're no longer as functional. And the other big problem from this is that because we have this downcycling effect, not only does it reduce the functionality, it reduces the price, I should say, of the plastic, because the less functional it is, the less expensive it is. And so there's not this economic driving force for mechanical recycling, because it just costs money. You're not able to really sell back anything at a profit, because without this driving force is that we see diversion of plastic waste away from recycling. So things like in Europe and Southeast Asia, we see a lot of incinerations, because plastics are made from oil. And if you burn them, they burn just like oil, and they are used to produce heat and energy. Problem there is that, one, you're emitting CO2, but there are other chemicals in plastics that are very undesirable to release into the atmosphere. As opposed to that, the vast majority of what we're seeing is landfilling and environmental leakage. So in the United States, we basically just throw everything in landfills, and we're pretty good at managing our waste. It either makes it into a landfill or it gets recycled, but there are a lot of parts of the world where what we see is just an immense amount of plastic just going right out into the environment. The way that I kind of see the picture right now is that, because we don't have a very high performing, motivated recycling infrastructure, the potential options, I should say, like incineration, landfilling, or just passive leakage, are really what dominate the vast majority of the plastics that we end up using.
You believe it's a policy change that needs to be implemented first before we can start on this plastic problem, and then from there are some other technical considerations that we could use to move beyond this kind of inefficient recycling. I also like that you talked about kind of these issues you don't really hear associated with recycling and plastics. Exactly in that term is, you mentioned CO2 emissions, you mentioned biological contamination, but you also mentioned fossil fuels and energy consumption. Can you talk a little bit more about exactly how these play into these larger issues, and what would be a beneficial policy change to get plastics where they need to be?
So I think one of the big picture things that we're thinking about here is trying to completely change the economy of plastics away from what we have is a single-use economy. Is that you go to the grocery store, or I guess we could back up even further there, is that if you really want to think about what the ramification of single-use plastic is, we go in the ocean on a platform and we drill the oil. We get the oil out of the ground, then we ship it onto shore. It gets cracked, it gets purified, which are both incredibly energetically expensive and intensive processes. And then the purified small molecules are then transformed into polymers. Then those polymers are then brought into plastic. The plastics are molded, and they're used, they're shipped to a grocery store, let's say. Then you go to the grocery store, you get your yogurt, you bring it home, you eat your yogurt, and then you throw it in the trash can, and then it goes into a landfill. What we have is this incredibly intensive process for what ends up being a rather passive usage or single usage. We have this single use economy where we're taking resources out of the ground. These are finite fossil fuel resources, and then they're just sitting in the landfill. What kind of the big picture change here, this doesn't just apply to plastics, this applies to almost any resource, is this idea of the circular economy. And I think a lot of people who'd be listening to this podcast have heard that term before. The idea here is that keeping resources within the economy to be used many times. And in theory, that's what mechanical recycling was pitched to us as a tool for creating a closed economy for plastics where they would be used over and over again. But that doesn't exist because of the inherent technological limitations of mechanical recycling. And so kind of the core thing that we're trying to do from the scientific standpoint is develop new chemistry-based technologies that allow plastics to be used over and over and over again in this circular economy. As part of that, it would be ignorant for a scientist or an engineer to think that our technology exists in a vacuum. We're seeing the same thing with trying to shift towards renewable energy is that in trying to develop a new economy for plastics, we can take a lot of the lessons from the struggles of people trying to advance technologies for, let's say, solar or carbon capture, is that you can see that no matter how good the technology is that policy from the government has to help aid in the transition, because for the most part, people aren't going to make the transition on their own. But from the science standpoint, we can try to make the process as desirable, as cheap, as energetically efficient as possible to drive down the cost of going through recycling in order to motivate people with the assistance of policy to use this process, because it's always just going to be cheaper for people to just throw out their plastic. But if we can create a process that pulls the resources out of those plastics that can be resold at a high price, then we start to install some sort of motivation into shifting towards the circular economy. And we have to do this because right now, I mean, we are using fossil fuels for these plastics, and this is a finite resource, and eventually we will run out. And so we need to shift the way that we think about these things. Circular economy and with the technology and the policy working together seems to be the way that I think about going with this, because the thing that a lot of people want to say, let's stop using plastics. And I completely understand that sentiment, but I think it's human nature to use the best thing out there. And plastics, at the end of the day, are truly a miracle material. Think about all the things they're used for in our lives. They have effectively shifted the way that we live. One could argue that we live in the plastic age along the lines of the Bronze Age or the Stone Age, is that plastics are the material of our age. Shifting away from their use seems far from a viable option. So developing technologies that offset the environmental penalties of using these plastics, in my mind, is a more viable route.
I think it's great that you're mentioning the circular economy, and that's not something you often hear about, fossil fuels being mentioned in that conversation. We do see, like you were talking about with renewable technologies and things like copper and other metals where we, see them used multiple times in their life. Yeah, and I like your multidisciplinary approach too. I like how you said you were drawing lessons from other industries, and I think that's an important lesson that we're kind of seeing as we develop as a planet towards these more ambitious goals. We're starting to see that, it's not just one industry or one profession or one scientific discipline that's leading this direction. So you mentioned that there's fossil fuels just left in these plastics. Can you talk a little bit more about what the process would be in an ideal circular economy, or if we did start kind of mining these plastics for these resources? What would that look like? What is the ideal situation for a circular economy involving plastic?
Yeah, that's a great question. So, I guess what I call it is closed loop chemical recycling. And so this is the idea that we have our plastics. Our plastics are primarily composed of polymers, which are long chains of molecules. And what the closed loop process would be, from kind of the highest level idea, is that we have our plastics, we break them down into their molecular building blocks, all the way back down to what they were originally made of, and then we build them back up. And this is kind of the only way that we could ensure that the product of the recycling process is exactly the same as what was put in. And so you're making brand new material from the same resources. This is something that we aren't able to do right now. And so kind of an ideal process, what that would look like, kind of more on the back end, I can't really get into the logistics of collection and the business around there. That's well outside my scope. But in terms of the chemical recycling itself, we would see collection of these plastics, specifically polyolefins, so polyethylene, polypropylene. These are the primarily fossil fuel derived chemicals that still make up over 70% of our plastics. We would melt them down at around 200 degrees, and then we would expose them to a catalyst that we're developing in the group. And this catalyst would react with the polymers in the plastic, breaking it down into its original building blocks. And the way you can think about this is kind of like a chain of Legos. And so what our catalyst is able to do is take that chain of Legos and pull off each individual piece by piece by piece, giving you back those original small pieces of Lego that then we can then move to another catalyst that would be able to put them back together. So what's really important in this process is that we're able to do that at very low temperatures because higher temperatures means higher energy consumption, which means higher cost. And through the chemical technologies that we're developing, we're trying to do this at very low temperatures, right about where the polymer or the plastic will melt. It becomes more processable. And then we can remake the polymer and remake the plastic, and it'll behave exactly the same. And so what we have is this closed loop process where what goes in comes out brand new, and we're doing it in a very energetically feasible, efficient process. Whereas current technologies, there are some claims of chemical recycling for these types of plastics, but in my opinion, those aren't true. What those people are doing are just applying an immense amount of heat to these systems, and it's forming random types of small molecules that are then sold as fuel for burning. So it's not closed loop. And so we want to shift from this idea that right now just giving the polymers one more life to shifting to a system where we can have almost infinite life of these polymers being used over and over again. And that's through the developing of these chemical technologies.
Well, yeah, that's great. First steps that we need to take to develop chemical technologies for plastics to be reduced to monomers more than one time. And then we also need policy initiatives to lead this plastic technology research. And then we also need policy initiatives to start incentivizing the actual recycling of plastics. Is that how you would kind of summarize the situation?
Yeah, I think that's pretty on the nose. What's really great, what we're seeing right now is that probably spurred on by China 5-6 years ago stopped importing waste from around the world. Most of our waste our plastic waste, our recyclables were going to China under the understanding that they were then recycling them. And then for whatever reason, their government decided to stop doing that. And why this was a really important event is because it forced a reckoning in a lot of the Western world, Europe, Canada, and the United States, a realization that we had terrible infrastructure. We had no idea what we were doing when it came to recycling, and we had no capability. And so all of a sudden we were forced to have this actualization of that we basically are just going to throw all of our plastics in the garbage can. In response to that, we've seen both a growth in scientific action on this, but we've also seen a dramatic growth in initiatives coming out of the government to fund this scientific effort. Agencies like the Department of Energy and the National Science Foundation here in the United States are investing very heavily in funding through initiatives focused on plastic recycling, funding fundamental and applied science in order to develop the technologies necessary to employ a closed loop chemical recycling infrastructure on the necessary large scale. And so we are starting to see massive government investment, at least on the scientific side, trying to develop these systems. From that point, that gives me some hope that if we do see the development of what appears to be a viable technology, is that we'll continue to have some sort of policy from the government that helps perhaps subsidize or motivate the collection and recycling of plastics to create an actual effect from the effort going into developing these technologies.
It seems like that with a lot of these technologies, the government just needs to give it that first initial push, and then the market kind of takes over. And I like your approach. I think it's innovative and great. And I think we've been talking about plastics for years. We've been seeing fish washing up on shore with plastics in their stomachs. It's a terrible situation all around. And I think I really appreciate your approach, and I really appreciate you taking the time to talk with us. Is there anything else you want to say on the subject, or is there anything you feel is important to know about how maybe people can get involved, or what they can do to learn more, or if there's any policy recommendations or next steps that maybe the average person could take?
Yeah, I guess I would say, just from the standpoint of everyone really thinking about what recycling is doing in their neighborhood, is try to find out what your locality, your township, your county, your state, what they actually will recycle and what they won't. This is kind of an eye-opening exercise, is when you realize that if you're a person who kind of tries to recycle everything, you realize how few things that you put in the recycling bin actually can be recycled. It's quite minimal. Products like that are unable to be recycled. And so when you start to wrap your head around how minimal recycling actually is in our current infrastructure, I think it'll motivate a lot of people to want to shift towards a new type of technology that allows us to really have an offset of the environmental implications of plastic waste. And, Overall, there are a lot of people who are working really hard in order to help offset this issue, but everyone kind of needs to do their part. You still need to try to recycle, but also try to reduce your waste. At the end of the day, the most effective means to not throw a thing in the landfill is to not use something that's only being used once. So do your best to avoid single-use product.
Great, thanks, Mike.
Well, I appreciate the time.
Yeah, I appreciate the interesting talk. It's fascinating stuff. We'll follow up and if we have any more questions.
All right, thank you very much.